Calculus for everyone. Feynman's quip about God's language raises many profound questions. What is calculus? How did humans figure out that God speaks it, or, if you prefer, that the universe runs on it? What are differential equations, and what have they done for the world, not just in Newton's time, but in our own? Finally, how can any of these stories and ideas be conveyed enjoyably and intelligibly to readers of goodwill like Herman Wouk, a very thoughtful, curious, knowledgeable person with little background in advanced math? In a coda to the story of his encounter with Feynman, Wouk wrote that he didn't get around to even trying to learn calculus for 14 years. His big novel ballooned into 2 big novels, Winds of War and War and Remembrance, each about 1,000 pages. Once those were finally done, he tried to teach himself by reading books with titles like Calculus Made Easy, but no luck there. He poked around in a few textbooks, hoping, as he put it, to come across one that might help a mathematical ignoramus like me, who had spent his college years in the humanities, that is, literature and philosophy, in an adolescent quest for the meaning of existence, little knowing that calculus, which I had heard of as a difficult bore leading nowhere, was the language God talks. After the textbooks proved impenetrable, he hired an Israeli math tutor, hoping to pick up a little calculus and improve his spoken Hebrew on the side. But both hopes ran aground. Finally, in desperation, he audited a high school calculus class, but he fell too far behind and had to give up after a couple of months. The kids clapped for him on his way out. He said it was like sympathy applause for a pitiful showbiz act. I've written Infinite Powers in an attempt to make the greatest ideas and stories of calculus accessible to everyone. It shouldn't be necessary to endure what Herman Wouk did to learn about this landmark in human history. Calculus is one of humankind's most inspiring collective achievements. It isn't necessary to learn how to do calculus to appreciate it, just as it isn't necessary to learn how to prepare fine cuisine to enjoy eating it. I'm going to try to explain everything we'll need with the help of pictures, metaphors, and anecdotes. I'll also walk us through some of the finest equations and proofs ever created, because how could we visit a gallery without seeing its masterpieces? As for Herman Wouk, he is 103 years old as of this writing. I don't know if he's learned calculus yet, but if not, this one's for you, Mr. Wouk. The World According to Calculus. As should be obvious by now, I'll be giving an applied mathematician's take on the story and significance of calculus. A historian of mathematics would tell it differently. So would a pure mathematician. What fascinates me as an applied mathematician is the push and pull between the real world around us and the ideal world in our heads. Phenomena out there guide the mathematical questions we ask. Conversely, the math we imagine sometimes foreshadows what actually happens out there in reality. When it does, the effect is uncanny. To be an applied mathematician is to be outward-looking and intellectually promiscuous. To those in my field, math is not a pristine, hermetically sealed world of theorems and proofs echoing back on themselves. We embrace all kinds of subjects: philosophy, politics, science, history, medicine, all of it. That's the story I want to tell, the world according to calculus. This is a much broader view of calculus than usual. It encompasses the many cousins and spin-offs of calculus, both within mathematics and in the adjacent disciplines. Since this big tent view is unconventional, I want to make sure it doesn't cause any confusion. For example, when I said earlier that without calculus we wouldn't have computers and cell phones and so on, I certainly didn't mean to suggest that calculus produced all these wonders by itself. Far from it. Science and technology were essential partners and arguably the stars of the show. My point is merely that calculus has also played a crucial role, albeit often a supporting one, in giving us the world we know today. Take the story of wireless communication. It began with the discovery of the laws of electricity and magnetism by scientists like Michael Faraday and André-Marie Ampère. Without their observations and tinkering, the crucial facts about magnets, electrical currents, and their invisible force fields would have remained unknown, and the possibility of wireless communication would never have been realized. So, obviously, experimental physics was indispensable.